In this video, I'll talk about total internal reflection. To explain total internal reflection, I have used an example here. So in this video, light goes from a denser medium, let's say from a liquid to an air. Higher the refractive index is, higher will be the medium will call denser medium. If you choose two mediums, and out of those two mediums, the higher refractive index medium is called the denser medium, and the lower refractive index medium is called rare medium. So the light must go, in order to have a total internal reflection, the light must go from denser medium to lower medium. Let's try to understand what the total internal reflection means. In order to explain this one, I have made this picture here. So again, in order to have total internal reflection, light must go from denser medium to rare medium. So let me write down denser to rare. It must go. That means let's call N1 and N2. So N1 must be greater than N2. All right? Okay. So in this case, the light goes from, let's call this is the 1. That's the light 1. This is 1. And this is 4. Let me call this one is a 4. This is 3. This is 3. And that's 2. And let's call this is 2. Okay. So if you look at this light here, it is going from denser medium, and then it will be refractive into the rare medium. Whenever the light goes from denser medium to rare medium, it bends away from the normal. Okay, whenever the light goes from denser medium to rare medium, it bends away from the normal. And you can see here, the light is going from denser medium. Instead of going straight, it bends away. Okay, and this is coming from the Snell's law. So that means more the angle of incidence is, the more it will bend. So now I have increased the angle of incidence. You might ask, what is the angle of incidence? This angle, this red line is the normal, perpendicular to the surface. And this angle is the angle of incidence. So now you see this angle is definitely greater than this angle. That means the angle of incidence is greater. So more the angle of incidence is, the more the light will bend. See, you can clearly see this purple line bends more. So that means again, if I keep increasing the angle of incidence, then the angle of refraction, this angle is called the angle of refraction. The angle of refraction will be more and more. And at one angle, the maximum angle of refraction you may have is 90 degrees. You cannot have anything greater than 90 degrees. That means you cannot have angle of refraction greater than 90 degrees. Okay, so if at this particular angle, if I look this refracted ray, the angle of refraction is 90 degrees. That's the maximum angle of refraction I can have. And the angle of incidence into the denser medium, for which the angle of refraction in the rare medium is 90 degrees, we call this angle as a critical angle. So here, I think this angle this angle we'll call as a critical angle. Okay, so what does the critical angle again means? The critical angle means the angle of incidence in the denser medium, for which the angle of refraction in the rare medium is 90 degrees. That we call as a critical angle. So what happens if we increase more than the critical angle? So if you increase more than the critical angle, then the light will be reflected back in the same medium. And this is what we call as a total internal reflection. So there will be no light. If you send a light ray at this angle or greater than the critical angle, the light will be reflected back in the same medium. And because of this critical angles, exactly based on this idea, you see the diamonds sparkle, the diamonds glow. It is because the light incidence onto the surface of the diamond in such a way that the angle of incidence is always greater than the critical angle, so it comes back in the same medium. Okay, so if the angle of incidence is greater than the critical angle, it comes back into the same medium. That's called the total internal reflection. So now, based on this idea, let's write down some equation. So we're starting with the Snell's law. Snell's law is n1 sine theta 1 equals to n2 sine theta 2. That means the n1 is the refractive index of this medium. Let me write down n1. And theta 1 is this angle of incidence. And this is the angle of refraction. n2 is the refractive index of the other medium. So now, if I choose one particular angle of critical angle, so at critical angle, what happens? So then theta c, I can write down as a critical angle, theta c. n2 is the other medium. In this case, this is the other medium, which is 1. The refractive index of air is 1. And angle of refraction, you can see the angle of refraction is 90 degree at critical angle. So that is the critical angle is 90 degree. What is the value of sine 90? The value of sine 90 is 1. So 1 times 1 is 1. So if I solve for the n1, the refractive index, I'll get 1 over sine theta c. So this is the relation between the refractive index and the critical angle. Okay. So let's use this idea to solve this problem here. Okay. So in this case, we have to find out this angle here, a critical angle. In fact, this is not a critical angle. This is greater. It has to be greater than the critical angle because of the total internal reflection. All I have to find out this angle is alpha. So if I look into this triangle, I can use tangent alpha to find out this alpha here. So the tangent alpha is rise over run. So this is rise and this is run. So rise is 20, run is 15. So if I solve alpha, I'll get 53.13 degree. So this angle I found out is 53 degree here. So theta c would be 90 because this total angle is 90 degree. So theta c, that is critical angle. In fact, it is greater than critical angle, but I'm simply calling critical angle, is 90 minus alpha. So if I solve, it will be 36.86 degree. That means the critical angle must be smaller than 36.86 degree because in this case, this is the total internal reflection. So now the refractive index and the critical angle relationship is given by this equation. So if I plug the value of theta c, I get 1.67. What does this mean? That means the refractive index of this medium must be 1.67 or slightly smaller than this one. It cannot be greater than this one. Or in other words, let me tell you a little bit different way here. So the critical angle must be smaller than this 36.86 degree. The critical angle of this medium must be smaller than this one. So if I solve the refractive index, it will be 1.67. That's what you have to find out here. All right. So this is it from this video. If you have any question, any comments, write down in the comment section below, and do not forget to like, share and subscribe the channel. Thank you very much.